Newton's three laws of motion defined and demonstrated. The first law of motion is sometimes referred to as the law of inertia. This law states that an object at rest stays at rest and an object in motion stays in motion unless acted upon by an outside force. Brett will throw the football to Ryan, while Lemmy is guarding Ryan. This relates to the first law because Brett is generating a force onto the football to cause it to move directly into Ryan's hands. Ryan's hands act as the force that is causing the ball to make a complete stop. He is acting as the outside force.
Go. Newton's second law of motion states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force. In the same direction as the net force and inversely proportional to the mass of an object. Johnson will drop a soccer ball and a football to the ground to demonstrate that force and mass does not affect acceleration even if the two objects are different in size and in weight. Both balls will land at the same time.
For every action, there is an equal and opposite reaction. The statement means that in every interaction, there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object. In baseball, when a batter steps into the box, he is engaged with the at-bat. As the pitcher throws the ball, the batter's hands go back to create stretch so that the batter can apply a force on the ball when the batter swings. When the bat makes contact with the ball, it transfers kinetic energy to the ball so that the ball is given enough push to move. The effect is the ball will be provided with enough force to go forward. That's gone. Yep. Thanks for watching our Newton's laws of motion video. Newton's three laws of motion defined and demonstrated. Newton's three laws of motion defined and demonstrated. The first. Go.
Tony Romo. Go.
Newton's second law of motion states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force. In the same direction as the net force, inversely proportional to the mass of the object. Johnson!
Come on! Close your eyes. Don't look at the
What? Okay, now.
One.
Newton's
Not
second
film.
law.
It's not filming.
Jeez. 3, 2.